What's the answer? What do I divide by? Come on. Z squared? No. What should I divide by? Well, let's do the first easy one. The first one that we did, r squared. Okay, and then yes, I should be angry if you don't know this. What is x over r? Since first chapter, what is x over r? What trig function? Cosine. What's y over r? Sine. What's r over r? 1. I know I'm ignoring the squareds, but it's the idea. This should be absolutely positively no problem. None whatsoever. Okay, then let's do what he said. X squared. X squared over x squared 1. What's y over x since the chapter 1? Tangent. What's r over x? X over r over x. That's what I do in my head. That's secant, right? Since chapter 1. Okay, so then what's x over y? Y over x? X over y. Cotangent. That's why I do that. Ticks. Okay, so then it's the other one. What's r over y? What's r over y? Cosecant. So that's why I think we get that one, and then the one previous one we divided by x squared. So there should be absolutely no reason why we don't and not able to write those down. All right. But now, if you're doing your homework, that worksheet I gave you, I love it. I caught someone last hour. He had his identity sheet out in front of him, and he started filling out the top of that worksheet. Do you think that's what we should be doing? Heck no. It's basically the quiz. That's what I just said right there. Try to think about it and write them in and then check yourself. But he's literally copying them. I could lead a horse to water. What can I make him do? You guys never heard of that comment? Drink. All right. So do what I say, and follow the directions. So frustrating. Okay, so now remember what I was talking about two components of this chapter that are the only relationship is usage of identities, but two completely different ways. We're doing the one way today, and that is to simplify trigonometric expressions. So take a big expression and make it smaller. That's really what it is. And all it is substitution. And the Rosetta Stone for what do I use to substitute is the identities. All right. The identities that you have before you that you should not stare at. You should have them turned upside down, think about it, right, and then check. Yep, I'm right. Otherwise, you're defeating the purpose. So I'll tell you right now, yes, number one is number one. Number one is the most successful thing you can do. Change everything in terms of sine and cosine, and then you might see some things canceling. And you should write this down. Those that don't, fine if you have an A triple plus. If you don't, then this is the beginning of where we make changes. But also in writing it, you find you don't need it, and you don't have to look at it anymore because writing it is a process of memorization. Now I would put a star by number 2, and it is number 2, probably secondary to number 1. Like it doesn't happen as much, but it does happen frequently. So number 1 is the biggest, most successful thing. And I will tell you this: you want to use a Pythagorean identity when you see trig squared. You might want to search for it. So I have trig squared. Let me check a Pythagorean identity first and see if that makes it smaller. And then I can go on and do other things like maybe number 1 after that. So I get people that use number 1 just arbitrarily and it doesn't work, and that's going to happen and it's okay. Then you just got to try something else. Things start getting messy, then stop what you're doing and try something different. And then not as much. These are very specific scenarios. If you see parentheses, you might have to distribute or FOIL. Hey, go to your worksheet. I want to make sure on the number real quick. Make a note to self. I probably should keep a copy over here. So make a note to self that number 15 on your worksheet. I love this worksheet. I'll tell you a quick story. Yesterday, 4th hour, right before 5th hour cat, like, you know what? I don't like the book assignment. I don't like how they simplify. They don't simplify very well in the homework. I'm going to look for a worksheet. Bam. First search. Second search. I found this worksheet online. But what leaked into there was number 15, which actually you should factor in that one. Didn't want to have that happen quite yet, but it did. It's not a big deal. I bet you those that are good at factoring will know exactly what to do. All right, so just make a note to self there. And then some on the back page are a little bit of the tougher ones. But I love this worksheet because they're like 1, 2, 3 steps tops. They're just real quick hitters, real quick getting the idea taken care of. But anyway, I wanted to mention that before proceeding on. And then I got something to say about this. This is where it gets weird. This is where the students kind of struggle, but it's only because of the fractions. That's it, right? Our fraction ideas. I hope you agree with this. This is what Lexi Samuelis is doing right now with bigger numbers. She's in 5th grade and she's dealing with common denominators and adding fractions. And I'm sure she's going to move on to multiplying and dividing. 5th grade. All right. So 5th grade math cannot stumble people in CAT. Wouldn't you agree with this? Of course, you wouldn't write it like this. You'd write 3, right? But isn't that true? Sometimes with this trig, you want to do the reverse of that and split this up into 2 separate fractions. So now that I write this 2, 1, and 4 thing down there below, we know that's true. And then I'll tell you real quick, listen. Well, you tell me, what's secant over secant? 1. Isn't that simpler? Right? And then weirdly, what's tangent? Let's have someone say that out loud. What is that as a fraction? Don't say 1 over cotangent. That doesn't help. What's tangent? We already said it once today, by the way. What's tangent? 1 over what? Well, no. What's tangent as a identity? Is it sine over cosine or cosine over sine? We don't have time for this. Sine over cosine. What's secant? 1 over cosine. Now, I just want to verbalize this. This is sine over cosine. This is 1 over cosine. Who cancels? Sine over cosine over 1 over cosine. Who cancels? The cosines. We're going to find that out. That ends up being sine. Sine of x plus 1. Isn't that simpler? Isn't that smaller? Isn't that reduced? Maybe not reduced is the correct word, but it's definitely simpler. There's less trig, less going on there. Okay, so I actually verbalize how that simplifies. Ooh, that kind of rhymed. I like rhymes. All right, and then, hey, remember I told you about that formula quiz? You have to fill in the formulas. And then I'll probably add a matching section, all right, that has these little quick, like I like to call one hit, like real quick, 1 step, maybe 2, and then I can match it with something as an from the answer bank. I'm evil, ugly Mr. Samuelis, just like my alter ego, evil, ugly Alex Trebek. Wasn't that fun? That quiz is Arr, yelling at you for not knowing what sign of a 30 is. Because we should know what it is. Anyway, I'm a little eviler. There'll be more than an equal amount of selections compared to the question. Really just make sure you know what you're doing. And sometimes an answer could be used more than once, possibly. Okay, so this is where we're we're not gonna walk around the room. After this, we're gonna walk around the room. I'll take care of these. Wait, what did I do last hour? Maybe I did have them. No, I guess I did start them last hour, and I should have done this. Hey, by the way, I just said it. What's tangent of x? What is tangent of x? Sine over cosine. That's how you start. Then we'll individualize this after. They won't see you on there. They probably won't even be able to hear you with my crummy microphone. I'm a little disappointed. Now, here's where students go crazy. Cosine, isn't that 1 over secant? Right? Remember I said that. Does that help? No, you want to keep everything in terms of sine and cosine because they're like variables. We want them as like terms, so to speak. Who cancels, everybody? The cosines. This is the grade school fraction stuff that Lexi's going to find out about. I think she actually already has done that. I think it's getting more complicated. So they're reviewing common denominator and then, doing more complicated fraction work. Because I can swear I've worked with her before on multiplying fractions. Don't you agree? Isn't that true? Sine of negative x equals negative sine x. So this matches with C. Okay, and then not on my matching, but on this one, you do get the process of eliminate. Okay, next one. Now I know secant squared is 1 over cosine squared. Does this help? Does this do anything? No, I mean, now what? Nothing's going to cancel. Nothing's going to happen. Oh, I remember what he said. Whenever I have a squared, I should look for a what? Starts with a P. P-Y. P-Y-T. Pretty young thing. Anyone know Michael Jackson? Nice. Pythagorean theorem. Did you say that? Someone say that? What is secant squared x minus 1? Don't hurt your leg there. What is secant squared minus fumble? Oh my gosh. Are you okay over there? All right. What's secant squared minus 1? What's secant squared minus 1? Tan squared. All you would have to do is subtract 1. Then secant squared minus 1 is equal to tan squared. Gotta get my pen again. So this is what I mean. Okay, that's simpler. Now let me look over here. Oh, I don't see it, but everybody, what's the letter? What letter does tan squared equal to? A, B, D, or E? Oh, A. Maybe you're paused. I remember a student back in the day, maybe not too long ago, was confused about. They're like, wait a minute, tan squared equals both sine and cosine being squared over each other. And I remember that being an issue with quite a few of them after I covered it. So I'm just going to write this real quick. Do you know tan squared is equal to tan of x squared, right? Right? That's what it means, and that's how you evaluate. And then we know tan of x is sine over cosine squared. You wouldn't have to write this down. I'm just climbing into your brain. Yes, tan squared equals sine squared over cosine squared. Tan to the fourth equals sine to the fourth over cosine to the fourth. Got it? The powers carry over, I guess is the best way I could explain this. Hey, everybody, what's secant? 1 over what? Okay, and then those aren't answering. You're coming. Your turn's coming. And we'll wait till you get the answers. All right, just telling you that right now. What's cosecant? 1 over what? Sine. Now, I'm going to show you a faster way of doing this. Hey, everybody, what's this operation right here? Add, subtract, multiply, or divide. It's divide. I don't ever want you to have to write this again. As a fatter mac, I'm going to do this a lot faster. Divided by 1 over sine. What's Lexi Samuelis already know about dividing by 1 over sine? Well, maybe not the sine thing, but dividing by a fraction. What does she know? You flip and multiply. Now, watch what I have here. Sorry, wrote that weird for you. That doesn't flip. Now, of course, we know what that final answer is going to look like, but I'm going to show you something. Hey, if I have secant up in the numerator, what does that mean I have in the denominator? What's the reciprocal of secant, everybody? Cosine. This is 100% what I want you to do and not all that stuff I did over there on this one. Hey, everybody, if I have cosecant on the bottom, what do I have on the top? Sine. Oh, then I hate this. I don't see the answer. Yeah, I do. What's the answer, everybody? E. So then it has you do one more thing. So even if you do that division and that flipping, it still leads to this. Oh no, that 41 looks weird. So let's skip to 42. What's 42, B or D? B. So again, paying attention and focusing here, these should start sinking in. Right, so then when I go around the room, we should be able to answer these questions. So what does that leave for 41, obviously? D. Now this is weird. You know what though? Look at your notes, good note takers. Look at your notes from Tuesday for you guys. Boom. Did we already write that? Anyone that took notes, we actually said, hey, these Pythagorean identities are weird. For instance, cosecant squared minus cotangent squared. That equals 1. And here's those notes again, because if I just subtracted cotangent squared from both sides, that would equal 1. And then lo and behold, hopefully it sticks where I was at there. Is this the one I was on? No. I don't know why this does this. So many odd things. Yep. Lo and behold, here it is. This is equal to 1. And we just had that in our previous set of notes. Now, that's not a simplify. That's what gets weird about this stuff. That's the opposite of simplifying. But that's why matching sometimes fun. Well, I wouldn't call it fun, maybe, but these things happen. All right, Colin. What hour is this? This is only 6th hour. Oh, we got one more to go. I don't know, for some reason I have in mind we're in 7th hour right now. Colin, what's cosecant? Boom shakalaka. Now, there's where students go nuts here. Colin, wouldn't you agree that cosine's 1 over secant? But why would I do that? The whole point of this is to get this in same variables. That's what you have to think about this trig. So this is cosine of theta over 1. And then what's tangent, Colin? Sine over cosine. And then we'll move to you, Marissa. What cancels? Okay, now be careful, Marissa. What's the final answer? Nice. Oh, wait, is that right? 1? Okay. Because I had some people, what do you think some people told me? Actually, it was 5th hour yesterday. What's an inkling that you might, what do you think they put? Everything canceled, so what's left? 0. No. What's 2 divided by 2? 1. When these things cancel, they're all 1s. 1 times 1 times 1. All right, so not 0, it's 1. All right, so someone 5th hour. Is that what you were going to change? Okay, good answer. All right, Beatrice. Still, yeah, what's secant? And then what's tangent? What am I doing? I'm sorry. That's a brain. Okay, a misfire. And then what's tangent? Who cancels? It is true. I don't want you to have to do the divide flip thing, but you can in your head. Look, divided by sine over cosine is times cosine over sine. Cosines cancel. So you can kind of think of it that way. But I would hope you wouldn't have to write it anymore. Okay, so this might be tricky, Beatrice. What's the final answer? Think of this as 1 over 1 now. So this is 1 over sine over 1. So what's the final answer? Oh, I think you were trying to say that it is 1 over sine, but what is 1 over sine? It's not that one. Cosecant. All right. And then here I'll tell you about if this was a written test, I'd take either one of those. If it was a matching, it'd probably be the second one, because I want it, in non-fractional form. That seems like the most simple when you have it in a non-fractional format, but either or on the written. Okay. All right. Amanda, what's cotan? Okay, so remember the objective is to get this in terms of sine and cosine. So tangent was sine over cosine. So what's cotangent? And then what is cosecant, which we literally just wrote on the last question? Okay, and then who cancels? And then what's the final answer? Cosine over 1 over 1 over 1. Cosine. Yep, and then there's no other thing to write for that. All right, so this is a lot of these. That's like in the front page of your worksheet. We have a lot of these types of questions. Love it. I like how it just kind of builds and simply moves on. All right, Ryan. Yet again, what's cosecant? And this is why I would do this in this one. I went through saying something last hour like you might think about someone might have thought about getting a common denominator, and that's going to happen coming up. But I know cosecant and sine they coincide with each other. I know cosecant's 1 over sine, so I'm going to do this. And that's the kind of thought processes you have to go through right here. We'll do some common denominator questions for sure, but this isn't one of them. What's secant? Okay, then I have one question for you. I'll give you a 50-50. There's really only 2 possibilities here. What is this? Is this 1 or is it sine squared? Which one is it? Oh, last hour got it wrong too. Divided by 1 over sine is I should have a tape of me with my fingers here and then move over here. Divided by 1 over sine is times sine over 1. So what's sine times sine? And then what does that mean the second thing is? There you go. So maybe the fingers, like with that, what I just did there, would be a smart thing to do. And then what is sine squared plus cosine squared, Ryan? I told you and everyone, you're going to write this a lot. This is going to happen a lot. What sine squared plus cosine squared equal to? Get this memorized. This is one of the big ones. What's sine squared plus cosine squared equal to? 1. Okay, so you're going to write this so many times that it eventually, through osmosis, I don't think that's the right word, but through doing something over and over and over again, you're going to remember that this is always equal to 1. Boy, is that a lot simpler than what we started with. All right? Caesar. What might be your inkling to do when you have a set of parentheses like this with something on the outside? Word starts with a D. Huh? Distribute. But don't. Because if you did, this would just make a mess. It'd be like, okay, I have sine and cotangent squared. I'll try to take cotan and make it cosine over sine squared. And it just becomes a mess because I told you whenever you have a squared, what should you look for? Whenever you see a squared, we should look for this identity. Michael Jackson, PYT, pretty young thing. What's PYT? Which kind of theorem? Pythagorean theorem. What's 1 plus cotangent squared? Think about it. Where do I have to scroll up? I know it's only your second day of looking at these. This is why we have to get them memorized, though, so we don't have to keep looking. What's 1 plus cotangent squared? Cosecant squared. Scrolling back down, maybe shrinkify it here. And now we got something. What is cosecant squared, Caesar? And now we got something. It's 1 over sine squared, by the way, right? And then I think I'm running out of students. So Michael, what is this reduced to, or what do we end up for a final answer here? Nice. 1 over sine. Pen is behaving a little better than last hour. Oh, it's terrible last hour. Now I'm starting to get a little glitchy here. All right, good. All right, and then Nasir, what might be your inkling to be here when you have 2 sets of parentheses like this? Starts with an F. Don't say factor. That's always like a knee-jerk reaction by students. FO, FOI, there's only one more letter. Foil, but don't. Not yet. Let's clean this up first, then foil. What's cotangent? Nice. What's, never mind. Who cancels? Yeah, I'm getting real glitchy here. Pen's barely hanging on. 1 more hour. I probably should do a computer restart. I feel like my computer's lagging. All right, now we're going to foil. All right, and then we're going to go to Amber here. Okay, so now he took care of that. That's just cosine now over there. Go ahead and foil. What do I get when I take this times this? This times this. I get the minus sign there. Just 1 times cosine. And then what's about the next thing? This times this. And then what about the last? I'll get the negative for you. What's cosine times cosine? There you go. And then what happens to the middle terms? Cancel. And then I only have 2 more students. I'll wait for the last one. So what's 1 minus cosine squared, Amber? Nice. Awesome. Done. Were you looking at your properties? Good. 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 Very good getting those fast. Okay. Natalie. Hey, remember that one time where you were the only student that weren't picked by the calculator? And I still picked you? I'm sorry. Hopefully you remember that the rest of your life. We're not going to do this one. Okay, this one I think we got to get a common denominator or something. Don't worry about it. Hey, think about this one real quick. Natalie, you're not doing this one either. But if I got a common denominator here, I'd have to multiply both top and bottom by sine. These are things that you're going to have to do on these coming up. By the way, what's sine squared plus cosine squared? It was just said recently. 1. This answer is 1 over sine. You get it? You get it? You get it? Okay, that's what that ended up being. All right, Amber. Don't do the splitting this up into two separate things. Remember what I said about squared? Search for a. Don't make me sing. Oh, I'm not Amber. I'm sorry, Natalie. Stop. Okay, but did you hear, Natalie, what Amber said? I have to sing P-Y-T. Pythagorean theorem. What is 1 plus tangent squared? I think we actually had this one. What is 1 plus tangent? You can probably look at your notes. We already did this replacement, I think, didn't we? Yeah, 1 plus tangent squared equals. What time's the bell ring? Did you say secant? Good. And then Natalie, we actually had this in the matching section where I said, you know what? If you have secant, okay, it's squared this time, up in the top, what does that mean could be put in the bottom? Cosine, but squared. And then Ben, why don't you take over from here because I only have 2 more things for you to do. If I have a cosecant squared on the bottom, what does that mean we have on the top? And then Ben, final answer, what is sine squared over cosine squared? And that is much simpler than what you started with. So you'll see that these are like puzzles, really. And that's all I got to say about that. Close it off. Have a good spring break.